Okay, as I said, let's continue. Let's start our third chapter in our course, Engineering Electronics 2. So, as I said, in chapter 2, we have discussed very important wave shaping circuits like clipper, clamper, and another very important device, 555 timer. So now let's continue our chapter 3, which is another very important chapter. So in this chapter, we'll see voltage regulators specifically and power supply circuits in general. Because voltage regulator is part of a power supply, we'll discuss voltage regulators specifically in detail in this chapter. Okay. So, as you know, systems both in telecommunication or in control or in electrical systems, circuits and these systems, they need DC power supply, right? Most systems needs a DC power supply. So it's very important to provide fixed voltage, fixed DC voltage for these systems, fixed regulated voltage, DC voltage for these systems with enough amount of current. For example, now I'm using my laptop. It consumes a DC voltage plus 18 minus 18 volt, sometimes 24 plus 24 minus volt DC, regulated fixed DC 18 plus and minus DC consumed by my computer right now. And this computer needs certain amount of current. So my power supply unit must provide what? The required amount of current to drive the system plus the amount of voltage, DC voltage, must be a fixed amount. It must be regulated. So to do this job, we have option, what we call it, batteries, right? Batteries are very good DC sources. You can buy 9-volt battery, you can buy 12-volt battery, and so on. So it's very good to supply the required amount of fixed voltage. 12-volt battery supplies 12 volts. But there is one big problem with batteries, which means batteries cannot supply enough amount of current to derive these high current loads. Most loads, most systems, they drive by high current. They need high current. But battery, your battery, 12-volt or 9-volt battery, is good in terms of voltage, but the amount of current supplied by these batteries are not enough most of the time. So what is the solution? The best solution is to take 220-volt, 60 hertz line voltage, okay, the AC voltage we get in our main supply, and convert it into usable DC voltage. That is the best solution. That's what we use in most systems. Now I'm using my adapter here for the laptop, which is connected to the AC 220. That AC 220 60 Hz line converted into usable DC voltage, and the computer gets enough amount of current. So that is another mostly used solution. So what are the solutions? First point, most systems, they need what? They need a DC power supply, DC voltage and current. Where this DC voltage and current, we can't get it from battery, first choice. But there is one problem with battery. What's the problem with batteries? They cannot supply the required amount of current to derive these high current frequently used systems. So the alternative solution, the best solution to solve this problem is convert the AC voltage from 220 60 Hz AC voltage from the mains into usable DC form and supply that to your system. Okay, so as I said, we have the AC 220 volt AC and 60 Hertz from the main supply, right? Now, this AC 220 volt 60 Hertz from the mains needs to be converted into usable DC form. So for that, the first device comes to picture is a transformer, right? We have a device called transformer. Okay, transformer. So this transformer step down this high voltage AC into low voltage AC. So it's a step down transformer which converts this high voltage AC into, let's say, 90 volt AC. Still it is AC, but it's stepped down, okay? Due to based on the number of turns ratio between primary and secondary. We'll come to that later. So it converts into low AC. The next subsystem is the rectifier package. Rectifier, which this case it is pure AC signal, okay, pure AC signal, 90 volt. Here high volt AC signal. So this high volt AC down converted into this low volt AC signal. Then the next system comes to power supply unit is called rectifier unit. This rectifier unit remove or clip all the negative part of the AC signal. Okay, it's just like a special case of a clipper circuit. Now there is no negative part. All will become what? Positive. Okay, so in this case, here the average DC voltage, as we have discussed in clapper, the average is 0 here for AC. But now this is average is because it's all positive. The average is what you call the DC voltage here. In this case, equal positive and negative, so the average will be 0. So after rectifier, this is not a pure smooth DC. This output is not smooth. Okay, it's not smooth. We call this ripples. Ripples. So we need a device to remove these ripples. That is a smoothing filter. Next device in power supply systems is called a smoothing filter. Capacitors. Okay. After smoothing, we have a pure voltage DC. A pure voltage DC. So the AC voltage from 220, 60 Hz, converted into usable DC, let's say 24 volt DC. Okay. By using what? The transformer, rectifier, and smoothing filter. Transformer step down the AC from high voltage to low voltage AC. Rectifier convert this AC into DC. It's a diode circuit. We have discussed diode circuits in clipper, how we clip negative part or how to clip positive part. So rectifier is a diode circuit which is used to convert DC into AC into DC. But the output of this rectifier is not smooth DC. There is a ripple. So this ripple must be flat, must be smoothed by using a capacitor called the smoothing filter. Now, as you can see here, there is one problem. So look here. So this is we are not using 120, we have 220 volt AC signal. This is our AC line using a transformer. It's called a step down transformer from high voltage AC to reduce DC voltage. Sorry, reduce AC voltage. Transformer input and output was AC, but it is reduced. Then there is a rectifier part which converts this AC into DC form. This is a rectified DC. But this rectified DC is not smooth. There is a ripple here, as you can see here. So to remove this ripple, we use what we call it filter, smoothing filter. Then this AC converted into a DC voltage output. Okay, a DC voltage output. But there is one problem with these circuits. This DC voltage output from this power supply circuits. When you say power supply, we have transformer, rectifier, and smoothing filter. We get a DC. We convert AC to 20 into DC. But there is one problem now. This DC voltage is unregulated. So if you design for 20 volt, our system needs 20 volt DC here, we can just convert this AC into 24 DC. But this DC voltage is unregulated. What does it mean unregulated? There is fluctuation. Sometimes it may increase, sometimes it may decrease. It's not fixed. It's not maintained at a fixed value. When the input AC voltage fluctuates, when it increases or decreases, the output DC also increases or decreases. It's affected by our input. AC input affects the DC. Or if you change load, not only the input AC, if the load changes, this DC value fluctuates. So this is a big problem. Okay, this is a big problem. What will happen if you are using unregulated power supply in your system? What will happen? Maybe two things will happen. If you are using unregulated power supply, there will be two things. First, the system will not work properly. For any system, electrical, control, telecommunication, any system, to work properly, it needs a regulated DC input. Okay. If the DC input is not regulated, it fluctuates, your system will not work properly. So for our systems to work properly, we need what? A constant fixed DC voltage. Okay, so that's one problem with unregulated power supply. If you are using unregulated power supply, your systems in electrical or any other telecommunication systems, transmitter or receiver circuits, when you come to electrical systems, control units, they are not working properly. Okay, the system will not work properly because of this DC input voltage fluctuation. That's one problem. Second problem, even the device will be damaged if it is, for example, sensitive device like digital ICs. If one digital IC is 15 volt, okay, let's say op-amp 741, it needs maximum 15 volt DC. If you are connected unregulated power supply, if you give it 20 volt DC, the IC will be damaged. Okay, my computer, if the voltage is not regulated, if high voltage DC comes to the computer internal part will be damaged. Why? Because it's made of very sensitive digital ICs. So because of two reasons. What is the first reason? To protect our systems from damage. Sensitive systems will be damaged by this fluctuated voltage, or the system is okay but it does not work properly. So to avoid these two conditions, what is the solution? So as you can see here, unregulated supply has two problems. What is the first one? It will destroy devices. Second one, improper operating characteristics. Improper operating characteristics. Okay. So what is the solution? What is the solution for this problem? Come here. So we have AC, we have transformer step down, we have our rectifier, bridge rectifier, we have a filter. So this is what? Unregulated DC. Then what is the solution? We have to connect a device after the filter. After the filter, we have a DC, but it is what? Unregulated DC. Okay, it's unregulated DC. Now we connect a voltage regulator. This unregulated DC becomes regulated. So you see here, voltage is what? Regulated. Which device is used to regulate our voltage? We call it what? Voltage regulators. They are called voltage regulators. They are everywhere in our systems. They are automatically adjust the DC voltage. Whatever fluctuation here, the AC signal may increase or decrease, but the output is always remains what? 20 volt DC. No change. It maintains 24 volt DC. The AC signal fluctuation does not affect the output DC. Because of what? This very important device, what we call it? A voltage regulator. Okay, it's called a voltage regulator. So, as you can see here, transformer, rectifier, filter, then one device comes to picture, a voltage regulator, which converts this unregulated DC into a regulated DC. So in this chapter, our focus will be this part, voltage regulators. We'll see specifications, we'll see devices, which devices are used for regulating fixed voltage regulator ICs, as you can see here, variable voltage regulator ICs. That will be our main objective in this chapter, chapter 3, voltage regulator ICs.